Aura, public. Welcome back. Now we know that we need a few classes to get our UI system started. So I'm going to go into C++ classes Aura, public, and we'll make a new C++ class here. And I'm going to choose all classes and search for user widget. I'd like to have my own base user widget C++ class. And I'm going to use this class for my user widgets in this project. That way they're all compatible and share the same base functionality. So I'm going to choose user widget. Widget, go to next, and I'll place this in a folder called UI/widgets. That way I can have all UI related stuff in UI and my Aura user widget in widgets. In fact, I'll just say widgets to keep with the convention that I'm using throughout the course. Without the S at the end, we have a player folder, a character folder, and so on. We're going to have a widget folder, and this will be called Aura user widget. This will be our specific user widget. I'm going to create the class, and I'm also going to create the widget controller class. So I'm going to right click new C++ class, and my widget controller is just going to be a simple object. So we'll have a UI object, and I'm going to click next, put this in the UI folder /widget controller folder, and this will be called my Aura widget controller class. So we can make widget controllers and base them off of this class, and this will be designed to be the controller for all widgets. In our system. So I'm going to click create class and close the editor. And here in Writer, I should be seeing the UI folder popping up in both public and private. And there it is. It took a second, but now I have UI, and in UI we have widget, inside of which we have Aura user widget, and widget controller, which contains Aura widget controller. So now that we have these two classes, we can start making them compatible with one another. Now my Aura user widget class, this will be our base class for widgets. I want this class to have a member variable for its widget controller. I'd like our widgets to have the concept of a controller. So any given widget is going to have its controller set, and when the widget controller broadcasts data, our widgets will receive that data and respond to it. So our dependencies will be one way from Aura user widget to Aura widget controller. The widget controller isn't going to know what widgets it's associated with, but the widgets themselves will know what their controller is. So we're going to make a public section, and here in the public section, I'm going to have a TObject pointer, and the type for this will simply be UObject. So it's going to be very generic. The way we're setting this up, the widget controller could literally be any UObject. That makes it a little bit more versatile. And we're going to call this pointer simply widget controller. Now, widget controller is going to need to be accessed from blueprints, as all of our user widget classes are going to be widget blueprints that use this C++ class as their base. And widget controller should be a U property with access in blueprints. We're going to make it blueprint read only so that we can only access but not set it directly. Now, most of what our user widgets are responsible for is the visuals for the widgets. Basically, they're responsible for what the widgets look like on the screen when they receive data. And whenever we set our widget controller for a given user widget, we're going to want to initialize the visuals. We're going to want to do something visually in response. In other words, as soon as the widget controller is set, we now know that we can get whatever data we want from that widget controller. So we're going to want a sort of begin play-like function that we can call as soon as the widget controller is set. So I'm going to make a protected function. I'll make a protected section and make a void function called widget controller set. And I want this to be a blueprint implementable event. So I'll give it a ufunction macro with blueprint implementable event. So this way, whenever we set the widget controller for a given widget, we'll also call this function widget controller set. And as soon as that happens, anything we want in the blueprint that we would like to do in response to the widget controller set, we'll do that in the blueprint. So that means we should associate setting the widget controller with calling widget controller set. These should be tied closely together. So what we'll do is we'll make a function to set the widget controller. I'll put this right at the top of the public section, and it's going to be a void function. It'll be called set widget controller, and it's going to take an input of type uObject, and we'll call this in widget controller, like so. And I'd like to be able to call this from Blueprint, so I'll make it a U function with Blueprint callable. So we can set the widget controller from Blueprint if we want, and I'll generate the definition, and the definition will be simple. All we want to do is set widget controller to in widget controller, but we also want to call widget controller set. Now this is a Blueprint implement controller, or that widget the definition, so we can set the widget controller from Blueprint if we want. And I'll generate the definition, and the definition will be simple. All we want to do is set widget controller to in widget controller, but we also want to call widget controller set. Now this is a Blueprint implementable event, so if we set the widget controller, we should do so with the setter, and that way this will be kicked off, and we're safe to assume that when we implement widget controller set in any blueprint, we know our widget controller will be set as it was just set. Okay, perfect. Now or set as it was just set. Okay, perfect. Now Aura widget controller is going to be responsible for getting any data from the system, from the model in this architecture. That means our ability system component, our attribute set, our character, anything that really matters relating to our data, the widget controller will be responsible for getting that data and broadcasting it over to any widgets that have their controller set to it. So what I'd like our widget controller to have is a set of variables from which it's going to get any information, any data. And for the purposes of this game project, I'm interested in 4 main classes. I'm interested in the ability system component, obviously. I'm interested in the attribute set. And I'm also interested in the player state and the player controller. Throughout the game, our widget controller may need to have access to the 4 of those. So that's how our dependencies will be set up for our widget controllers. We're going to have those 4 variables. So I'd like to make a protected section, since any child classes of Aura Widget Controller are going to want to access these to get data from them or to subscribe to delegates broadcast by them. And those 4 objects are going to be the player controller, so we'll make a T-object pointer of type A player controller, and we'll call this player controller. And this gets a U property. And I'm going to give this a blueprint read-only with a
Oylağandır şu gece Oylağandır
category of widget controller. So the widget controller is going to have a player controller variable. It's also going to have a player state variable, so I'm going to make a t-object pointer of type a player state, as we will have important information on the player state that we'll need to know about in the HUD. So we're going to call this one dependencies will be set up for the model in this architecture. That means our ability system component, our attribute set, our character, anything that really matters relating to our data, the widget controller will be responsible for getting that data and broadcasting it over to any widgets that have their controller set to it. So what I'd like our widget controller to have is a set of variables from which it's going to get any information, any data. And for the purposes of this game project, I'm interested in 4 main classes. I'm interested in the ability system component, obviously. I'm interested in the attribute set, and I'm also interested in the player state and the player controller. Throughout the game, our widget controller may need to have access to the 4 of those. So that's how our dependencies will be set up for our widget controllers. We're going to have those 4 variables. So I'd like to make a protected section, since any child classes of Aura widget controller are going to want to access these to get data from them or to subscribe to delegates broadcast by them. And those 4 objects are going to be the player controller. So we'll make a t-object pointer of type a player controller, and we'll call this player controller. And this gets a U property. And I'm going to give this a blueprint read-only with a category of widget controller. So the widget controller is going to have a player controller variable. It's also going to have a player state variable. So I'm going to make a t-object pointer of type a player state, as we will have important information on the player state that we'll need to know about in the HUD. So we're going to call this one player state. This one also gets a U property with the same specifiers and category. Now, in addition to that, we need the ability system component and the attribute set. So we'll make a t-object pointer of type U ability system component, and we'll add a forward declaration for that, and this will be called ability system component. And we'll also have a t-object pointer of type U attribute set. We'll add a forward declaration for that and call it attribute set. And just like the others, we need U property, and we'll make this blueprint read-only category widget controller. And now the widget controller has 4 main variables, and these are the variables that it's going to get the data from in order to broadcast to our widgets. So now that we have these, we need to set them up, right? We've just created classes. We never actually created any instances of these classes. And in our game, we're going to want a widget controller to control certain widgets. For example, we may want an overlay that shows health bars and things like that, but we may also want other widgets like menus, attribute menus, spell menus, things like that. And each of these is going to need a widget controller that can broadcast data to it. So we'll set that system up next. For now, this is looking good. We should compile our code, make sure we don't have any typos, make sure everything compiles, and we see that it does. Perfect. So we'll continue with this in the next video. I'll see you soon. Welcome back. Now we know that we need a few classes to get our UI system started. So I'm going to go into C++ classes, Aura, public, and we'll make a new C++ class here. And I'm going to choose all classes and search for user widget. I'd like to have my own base user widget C++ class. And I'm going to use this class for my user widgets in this project. That way they're all compatible and share the same events here. And so, welcome back. So now that we have an Aura widget controller and Aura user widget, we can now make some widgets based on this Aura user widget class. So the first thing we're going to want is some kind of way to show our health. That's what I'd like to start with. So I'd like to make a widget designed to handle that. Now for this project, I'd like health and mana to be represented as globes. If we go into assets and we check out the UI folder and go to globes, we have a number of materials. Notice that that's what these are materials. And we have an M flowing globe and an MI health globe. Let's double click MI health globe. We'll see that its parent material is M flowing globe. And this is a nice health globe that has clouds swirling. It kind of looks like red liquid. And you'll see that we have a number of parameters. It's a material instance with some parameters in it. And we're going to want to use this material. I would like to use this as a health globe material. So I'd like to make a widget that can use this in a sort of progress bar. So what I'm going to do is I'm going to go into the content blueprints folder, right click and make a new folder for the UI. I'm going to call this UI. And here in UI, I'm going to make another folder. And for this folder, I'm going to place all my progress bars, including the globes that we use as progress bars. So in progress bar, I'll just call it progress bar without an S. I'm going to make a widget blueprint. So I'm going to right click and go to user interface and choose widget blueprint. So I'm going to select that and a user widget and has a widget controller pointer. So globe, since I want both a health and a mana progress bar in the form of a globe, I'm just going to have a BP globe progress bar that these can both inherit from, and that way we can have some features inherited and we can set other features manually. So how are we going to use inheritance with widgets? Well, what we can do is first we can determine what the size should be for this, but I'd like the size to be something we can override in child classes, just in case we need to do something that's a sort of... So dragging a size box in, we now have this box that right now fills the entire screen. But if I change this from fill screen here at the top right to desired, I now have the ability to override the size. Over here under the details panel, under child layout, we have width override and height override. I can under child layout to override the size at the top right to desired. I now have the ability to override the size. Over here under the details panel, under child layout, we have width override and height override. I can override this. So for example, I can check these checkboxes and set these to values that I want, such as say 250 pixels each for width and height, just as an example. But if we want to be able to override this in child classes, well, how exactly can we do that? Well, what we could do is we could create variables for the width and the height, and then we can set those over in the graph territory. So the size box, I'm going to rename this to actually sizebox_root. So we can treat this as a sort of root widget here in globe progress bar. And if we go over to the graph, then here in globe progress bar, and if we go over to the graph, then we have these events here, and the one I'm interested in here is an event pre-construct. Now this is similar to the construction script in regular actor blueprints, in that if we change any properties here on this blueprint, this widget blueprint, then this will be fired off. Now I'm noticing I named this BP. This should actually be WBP. I just like to have W for widget blueprint. So I'm just going to really quickly rename this to WBP. So in this widget blueprint, this will fire off when we change something such as a variable. Now, what we can do is we can make variables for the width and height for that size box, that root. So if I click plus under variables and create a new variable called box width and change this to a float and then make another variable called box height and let that be a float, then we now have these variables that we can use to set the width and height of that size box. So for example, if I compile this, I can set box width, I can give it a default value of 250, and I can set box height, I can give that a default of 250. And then here in event pre-construct, I can take that size box root that we have here, and I can set properties on it. Now I need to come up here in the details panel and check is variable and compile so that back in the graph, I can see the size box root and drag it out and get it. And back in the graph, details panel and check is variable and compile so that back in the graph, I can see the size box root and drag it out and get it. And what we can do is take size box root and we can call set width override, and we can pass in our box width. So we can get that, pass it in, and hook that up to event pre-construct. And we can also set the height as well. So I'm going to copy size box root with Control D and drag off of it and call the function set height override. If I call that, I can hook that up and I can drag out our box height and hook that in. And now if we change these values, as soon as we change them, we should see that size change here in the designer tab. For example, if I go to box width and change this from 250 down to say 80 and go back to designer and hit compile, now we see that it's skinnier. It has a width of 80. So this is a nice way for us to just have variables that we can set, and we can set these on child widget blueprints that are based off of this widget blueprint. Now we'd like to keep these nice and organized, so I'm going to highlight these nodes and right click and collapse to a function. That way we can update our box size all in a single function. I'm going to call this function update box size. And now our event graph is nice and organized. So this is sort of the pattern we're going to take to inherit child widget blueprints from our base widget blueprint. And this is how it's done in Fortnite. As you can see some GDC talks where they talk about how they do this in Fortnite, and this is how they do it. Now we have a size box that determines the size for our widget and anything that's underneath it in the hierarchy. I'd like to stack things on top of each other, and to do that we need an overlay. So I'm going to get an overlay and bring that up onto my size box root. And I'm going to call this overlay underscore root. That way we know that this is sort of the root overlay, and we can place things on top of it. Now I'd like several things. I'd like a background image, something that can sort of be a ring or a frame for our health globe. We know that this is going to be the progress bar is this health globe, right? So we're also going to want a sort of ring or a background. Now, we have plenty of ring assets. If we go to assets and go to UI, we can go to rings and we have globe ring. Globe ring, there's two styles to choose from here. Here's the globe ring texture, and then we have a globe ring 2, which is a little bit more pale. So notice one has more saturation in the color, the other is a bit paler. I'm going to just use the regular globe ring here. So I'd like to add an image here into our WBP globe progress bar, and I'm going to set it to that globe ring. But this is also something I'd like to be able to override in child classes. So what I'm going to do is first drag in the image. I'm going to get an image and drag it onto the overlay root, and this image is going to be our background image. I'm going to call this image underscore background. So our image background here is something I'd like to be able to set with a variable as well. So what I can do is I can take this image background, I can go to horizontal and vertical alignment and choose fill for both. And I can also come into the graph tab and I can make a variable for the brush. That's what we use for images in widgets, is a structure known as the brush. So I can make a variable here. I can click plus. I can call this background brush, and I can change its type. I can search for brush, and the type that I want is slate brush. So I have a slate brush variable, and I can use that to set the brush for the background here, which means our background needs to be a variable. So we're going to check that in the details panel, compile that, and come back to the graph so we can see that we have our image background. Now, already I'm starting to see that these are getting a little bit mixed up. We have our variables, and then we have our widgets that are exposed as variables from our hierarchy here. So I'd like to put these sort of in their own categories. I'd like to have at least one category for the overridable variables. So for the globe progress bar, I'm going to select box width and come down here to the properties and find category and change this from default. I would like this to be in its own category. I'm going to call this globe properties. So now we have this globe properties, and I can put box height in globe properties as well. And I can put background brush in globe properties as well. So now we have the globe properties, and they're different from our properties as well. So now as well, and I can put these, and I can put box height in its own category. I'm going to call this globe properties. So now we have this globe properties, and I can put box height in globe properties as well. And I can put background brush and globe properties as well. So now we have the globe properties, and they're different from our widget variables that we have here. Now I'd like to take my background brush and drag it out and select get. And I'd also like to get my image background, that widget that we exposed as a variable, from over here in the designer tab, this image background. I'm going to take that image background and I'm going to call set brush. Now calling set brush requires a slate brush structure. For that, I'm going to use background brush. I'm going to drag that in and hook it up and select my background brush and scroll down to the background brush default value, and I can set this. I'm going to choose that globe ring. I'm going to search for globe ring. And this, I'm going to choose the background brush default value. And I can set this. I'm going to choose that globe ring. I'm going to search for globe ring and choose globe ring and compile. And if I go back to the designer tab, now I see the globe ring set. So we're giving this base widget blueprint a default value for that globe ring here. Okay, and now that this is driven by a variable, if we inherit from this in a child blueprint class, we can set that background brush and change that background if we'd like. Now, I'd also like to refactor this into its own function, so I'm going to highlight these nodes, right-click, and collapse the function, and this can be called update background brush. And we have that encapsulated into its own function. Now, in addition to a background, we want the progress bar itself. So for the progress bar, I'm going to want, well, a progress bar. So up here in common, here's progress bar. If I drag that out, I can put it onto the overlay. That's what overlays are good for, is stacking things on top of each other. And the progress bar itself, that can be set to fill horizontally and vertically. And this progress bar is going to want a style. Now, I want the style here to have a fill image. If I expand fill image, here it is. To have a fill image, if I expand fill image, here it is. And I can set this to an image. If I expand fill image, here it is. And I can set this to a default value. Now I want to use my mi underscore health globe. That'll just be the default value here. So mi health globe, we'll set that for the fill image. And if I take my percent and drag it all the way up, I can see what it looks like when it's all the way full. Now that doesn't look right, does it? It looks completely black. So we need to find out why. Well, if we scroll down here in the details panel, for one, here's a fill color and opacity. I'm going to want that set to completely white. So I'm going to open the color picker and bring the saturation all the way down and click OK. So that's better, but it's all the way down and click OK. So that's better, but it doesn't all the way down. So I'm going to open the color picker and bring the saturation all the way down and click OK. So that's better. But all the way down and click OK. So that's better, but it doesn't look like a globe, does it? So we're going to scroll all the way back up to fill image. And here's what we want to do if we want to show this as it looks here in our mi health globe. What we have to do is right here under draw as, we have to change this from box to image. If we change that to draw as image, well, now this is what it looks like. It looks like it does in our material instance, and that's what we want to use. Now for the background image, I don't want that gray there. So what I'm going to do is expand background image, and under tint, I'll actually open that color picker and drag the alpha down to 0 and click OK. So now we color picker and drag the alpha down to 0, and under tint, I'll actually open that color picker, expand and background image, and under tint, I'll actually open that color picker and drag the alpha down to 0 and click OK. So now we have really nothing for the background, which is what I want. As I already have a background image, I don't really want a background for the progress bar itself, and if I drag the percent down, there's nothing there. That's what I want. Now, later we'll have a second progress bar that will trail behind this one as it's changing, but we'll get to that later. For now, we're concerned with setting up the progress bar itself. Now, notice when I drag the percent down, we're going from left to right. I'd like this health globe to fill from top to bottom. So here under progress, I'm going to change bar fill type from, instead of left to right, I want to fill bottom to top. So as we start running out of health, it goes down like that. And as we go up, then we go up to the top. Okay. Okay, looking good. Now, we have a couple of issues, right? For one, we need some padding. We want that health globe to be a little bit padded so it's not covering the ring. But also, I'd like to be able to set this progress bar image, that material instance, in child classes, so that way we can change what it looks like, and maybe we can make a child that takes a blue health globe material, and we can use it for mana. So I'm going to take the progress bar and check is variable, go ahead and compile and come back into the graph, and I see that it's called progress bar 416, so actually I'm going to rename that to progress bar underscore globe. I think that's a better name for it. And in the graph, we'll drag out progress bar globe. And what do we want to set? We want to set our fill image. We're going to drag off and we're going to type style and choose set style. Now, why did we choose style? Well, all of this stuff under style has to do with what it looks like. We have the background image, we have the fill image. We're interested in having an empty background image, and our fill image is going to have a brush that we'd like to set. So what we can do here is we can drag off of the input for the set style, and we can say make progress bar style. And we'll make a structure that will satisfy this set node. And then we can set these various properties such as the background image. Now for the background image, we want an empty sort of 0 alpha transparent image. So I'm going to drag off of background image and choose make slate brush, and we'll make a slate brush structure here and expand it. And that way we can choose these properties. Now I'm going to get these two nodes out of my way. I'm going to delete them. And what I'm concerned with for background image here is setting my tint to a tint that has 0 alpha. That's all we did here in the designer. Under style, if we look at background image, we took our tint and we set its alpha to 0. So I'm going to take the tint, which is a slate color structure, drag off and choose make a slate color. And here I can choose a specific color. I can open the color picker and drag the alpha down to 0. Click OK, and now I have a slate brush whose slate color has 0 alpha. That's the background image for the progress bar style, so that takes care of the background. But for the fill image, this I would like to have a variable that I can change. So I'm going to make a fill image slate brush structure. So I'm going to go to variable, click plus, and this will be progress bar fill image. And I'm going to drag that in and set that for the fill image. And I'm going to compile and come down here to progress bar fill image and set this image to mi underscore health globe. Now whenever we call set, I can compile and see, well, it's set to this red mi health globe. But if I come back in here and change progress bar fill image to maybe a different color, if I search for perhaps mi mana globe and compile and come back to the designer, I see that it's now blue. blue. So changing this value for the variable is what's going to change what our health globe material looks like. Now I'm going to take that progress bar fill image and set its category to globe properties. So it's in here. With our other variables. And I'm also going to, of course, collapse it into its own function here. So I'm going to highlight all of this, right click, collapse to function, and this one will be set globe image. And now we have that. That function, and if we change our globe image, that's going to change it here for our widget. Now we do want some padding, don't we? So if I take my progress bar globe, get that, how are we going to set the padding? If we search for padding, we see set border padding, but if we look in the designer, we see this padding here is under slot, overlay slot. So if I drag off and type in slot, and we get slot as overlay slot, now we have the overlay slot object reference. And if we drag off of that and type padding, now we see that we can set the padding directly here. And this is a margin structure. If we drag off and choose make margin, we'll make one of these structures. And we have left, right, top, and bottom, and we can set the padding here. So what I'd like to do is make these variables that we can set, and then in child classes, we can override them if we want. Now, what values do we want the defaults to be? Well, we can just set padding here to say 5. Nope, that's not enough. We can set it to 8. Almost good enough. Let's do 9, maybe set it to 10. And I think 10 is looking pretty decent. So 10 is a good default value. So it's up to us if we want individual left, right, top, and bottom, or if we just want one value to set them all to the same one. Really doesn't matter. So pretty decent. Maybe set it to 10. And I think 10 is looking pretty decent. So 10 is a good default value. So it's up to us if we want individual left, right, top, and bottom, or if we just want one value to set them all to the same one. Really doesn't matter. For now, I'm going to use a single value. If in the future we decide we need these all for separate variables, we can do that. But for now, I'm going to drag off of one of them left. I'm going to promote a variable and simply call this globe padding. It's the padding for our globe. I'm going to set its category down here to globe properties. And I'm going to use globe padding for all 4 of our parameters for make margin. And that's going to be the margin that we use to set our padding. Now, hooking this up and compiling. You see, well, it looks like we have 0 padding, right? That's because globe padding has a value of 0. But if we set it up to 10 and compile and look, there we go. We have a padding of 10. So now we have a parameter to set our padding. So let's go ahead and collapse this to a function and call this update globe padding. And since all of these are called update, except for set globe image, I'm going to change this to actually update globe image. So we're consistent. And we have our update functions being called here. Now, these are for before the game starts, right? So this is just all for configuring how this is supposed to look as we're building our widgets, right? It's not really for changing at runtime or anything like that. Okay, so that's almost everything. There's one last thing I'd like to do, and that is that when our globe is getting low, when our percentage is dropping for our progress bar, I'd like there to be a sort of glare, a bit of a glass reflection, so it looks like we have an actual glass globe here. So that's essentially going to be an empty globe material. For that, I'm going to drag in another image onto my overlay root. I'm going to rename this to image underscore glass. We'll just call it glass for lack of a better name. And I'm going to set horizontal and vertical alignment to fill. And we're going to set that image. So let's go back into our event graph. We actually need to check is variable, right? And come back in here and compile. And then we have our image glass. Let's drag that out. And just like we did with our update globe image, right? Remember, we had to have a slate structure. We are going to want a slate variable to update our image glass. And we're going to call set brush. So calling set brush, and we'll make a variable for that brush for the glass. So I'm going to click plus, call this glass brush without typos. I'm going to remove that typo. And it's a slate brush. I'm going to typos. I'm going to call this glass brush. without typos. I'm going to remove that typo. And it's a slate brush. I'm going to hit compile so I can give it a default value. We'll get an error because I don't have anything plugged in there. We'll fix that shortly. But for glass brush, there exists a material instance in this project called mi empty globe. I'm going to choose that, and I'm going to drag in glass brush, get it, and set our brush. And I'm also going to set this glass brush category to globe properties, so it's in there with my variables. I'm going to compile, go back to designer, and there's the glass brush, and I can really see it if I select my progress bar and drag that progress percent down. You'll see that there's the glass brush, and we kind of want that to have some padding as well, don't we? So let's take that image glass and experiment with padding values. I'm going to hit a 5. Seems a little low. Let's try 8. 8's a little too high. 6 looks pretty good. Maybe 5 is actually pretty good as well. If I drag that percent up, I want these to overlay with each other. I don't want to see a sort of trail or ghost image. So I'm going to actually try a value of 4, 6, 7, 8. I think 8 looks good. Maybe even 9. Maybe it is 10. Maybe 10. Yeah, 10 is going to be it. So 10 is going to work. So image glass, padding 10, we're going to create a variable for that. So we're going to take our image glass, and we're going to do what we did for the padding, update globe padding here. We're going to get the slot as overlay slot and call set padding. So take image glass, drag off, slot as overlay slot, and we're going to call set padding. We're going to take in padding, drag off, make margin, and we're going to make a new variable for our padding. And it looks like actually we're using 10 for both of these. For now, I'm just going to use the same globe padding. And later, if we make a child that uses a different material, and for some reason we need a different globe padding for the glass, we can change it then. But for now, it looks like we can use the same one. So that's going to look good. We can compile and look, it's looking good. And as we drag that percent down for the globe, then we still have that sort of glass look. And it's a little heavy, which means I might want it to have a bit less of an alpha. I might want the alpha to be turned down a little, which means I can take my fill color and opacity and bring it down a bit. Actually, not this one. This is the progress bar. I want to get image glass. And for this image, I want to take color and opacity and bring that opacity down to about 0.5. Now, if I want in the future, this could be an overridable parameter. For now, I'm just going to set it to 0.5 like this and just experiment with our percent bar and see that that looks pretty good. Okay, so last things last, we're going to take our set brush and collapse this into a function and call this update glass brush. Okay, so last and see that that looks and just experiment parameter. For now, I'm just going to set it to 0.5. Like in the future, this could be over opacity down to about 0.5. I want to take color, image glass, actually bring that opacity down to about 0.5. Now, if I want in the future, this could be an overridable parameter. For now, I'm just going to set it to 0.5 like this and just experiment with our percent bar and see that that looks pretty good. Okay, so last things last, we're going to take our set brush and collapse this into a function and call this update glass brush. And we're going to collapse this one into a function and call this update glass. This update set brush and collapse this. This into a function and call this update glass. Now all of our functions are, and the tidy for our, and now all of our functions are nice and tidy for our globe progress bar. And this is great because now we can make child blueprints based on this. And all we have to do if we want to change its size or its images, its progress bars, the materials, all that good stuff, those are parameters that we can change. So in the next video, we'll go ahead and make our actual health and mana progress bars based on this parent class. And we'll see how easy it is to inherit those. So great job, and I'll see you soon. Welcome back. Now that we have this WBP Globe progress bar, which is going to be a base class, we can make a health progress bar or health globe based on this. So I'd like to do that. I'm going to go into our blueprints folder into UI and progress bar, and we have our WBP Globe progress bar widget blueprint. Now, if we don't want to be confused, we could just call this WBP Globe base or something with base in the name if you want to do that. So if you want to rename it, go ahead. I'm fine with it. What I'm going to do, though, is go to User Interface, make a new widget blueprint, and choose my WBP Globe progress bar as the parent, and click Select. And this will be WBP underscore health globe. And I'm going to open health globe, and I'm going to change some properties on it. Now, the only thing I really care about changing is making this red. So I'm going to go to the Graph tab. I don't see my variables. That's because I want to click on the gear icon and show inherited variables. As soon as I do that, I now have a drop-down that I can expand, and I can expand globe prop. And I'm going to open health globe, and I'm going to be confused, we could just call this WBP Globe base or something with base in the name if you want to do that. So if you want to rename it, go ahead. I'm fine with it. What I'm going to do, though, is go to User Interface, make a new widget blueprint, and choose my WBP Globe progress bar as the parent, and click Select. And this will be WBP underscore health globe. And I'm going to open health globe. And I'm going to change some properties on it. Now, the only thing I really care about changing is making this red. So I'm going to go to the Graph tab. I don't see my variables. That's because I want to click on the gear icon and show inherited variables. As soon as I do that, I now have a drop-down that I can expand, and I can expand globe properties. Remember, we put all those variables into globe properties. That's really useful. Now we can change them, and I'm going to change my progress bar fill image by selecting it, and in the details panel, scrolling down and changing the image from MI Mana Globe to MI Health Globe. Now this is really cool. If I go back to Designer, I see that it's automatically changed, because when we change something, it kicks off that function. What was the function again? Pop quiz for you. Event pre-construct. That's a lot like the construction script. So it kicks off whenever you change something. We just changed that property. Okay, so now we set this to 256 by 256. I might be wrong, but if I go back to the base class and look at box width and box height, it's actually 250, not 256. But regardless, I want to see how big that looks on the screen. So I'd like to add this widget to an overlay, some kind of overall widget to fill the whole screen. I usually call those overlays. I'm going to make an overlay for Aura. So here in our UI under progress bar, I'm going to go one level out and make a new folder for the overlay. So I'll call this overlay. And here in overlay, I'm going to make a new widget blueprint. So user interface, widget blueprint, and I'm going to choose Aura user widget. I'm going to base all my widgets on Aura user widget. That way they can all have widget controllers, which we'll assign soon enough. But I'm going to call this WBP underscore overlay. The overlay is the overall widget we'll see on the screen, and it's going to contain a bunch of little widgets inside of it. So for that reason, I'm going to open overlay and add a canvas panel to it. Now, in general, you want to be pretty sparing with your canvas panels. The canvas panel is more expensive. That's why for my globe, I did not add a canvas panel. Instead, I used a size box and an overlay. These are a lot more efficient. But we're only going to have one overall overlay widget for the whole screen. And for that reason, I want to be able to set things by dragging them around. And to do that, we use a canvas panel. Now I'd like to add my health globe to this, so I'm going to search the palette for health globe, and there's my WBP health globe. I'm going to drag it out and put it right about there. So we'll place it just about right there. I'll compile and save, and why not, I'm going to anchor it to the bottom middle. So with my WBP health globe selected, I'll go to anchors and choose the bottom center right there. Now I can go ahead and see what this looks like on the screen. Now, just to quickly add this to the screen to see what it looks like, I'm going to go into my level blueprint, opening this drop down, going to level blueprint. I can add this WBP overlay to the screen, first by using create widget. And selecting WBP overlay. I can hook that up and take the return value and use add to viewport. Just to see what it looks like on the screen. So I'll compile, I'll save all before doing anything else and press play. And there's the health globe. And I'd say that's a pretty decent size for the health globe. So it's looking good. If it looks too big or too small, well, we made the size a parameter. And of course, we could just go into the overlay and click and drag to resize it manually. We can always do that. But remember, resizing things might make things less compatible. For example, making it small means that, well, now this needs the padding to change a little bit. So then you have to go in and change the variable for the padding here. Go into WBP health, take the padding here, globe padding, and maybe set it to 5. And here in overlay, we see that it's better. Now we could also go into the base class and open the eye icon, make these all editable here. Compile that. And now in the overlay with our health globe selected, we can search for globe properties. And here's our globe padding. We can increase it, decrease it, whatever we want until it looks great. And of course, we are using the same padding for that glass as well. So keep that in mind. The glass, that empty glass material, is changing because it uses that same globe padding. But that's going to allow us to resize it very easily. And we have access to those variables that we can easily change. So we know that we can change things if we want to, and then of course we can play test and see that looks a little too small. So, obviously that's just for example purposes, but I'm going to go ahead and just delete that and make sure my health globe itself has the width and height that I want. I'm okay with 250 for the height and width. And for the globe padding, I'm going to keep it at 10. And for the globe padding, I'm going to keep it at 10. And we'll just use that size for the health globe. I think that's a pretty good size. And I can see what it looks like in full screen mode by pressing play and hitting F. And that size, the globe padding, I'm going to keep it at 10. And we'll just use that size for the health globe. I think that's a pretty good size. And I can see what it looks like in full screen mode by pressing play. And hitting F11. To full screen it, and I'm happy with that. Okay, great. So now I have a WBP health globe. And it's just as easy to derive a child blueprint class from WBP globe progress bar for mana. And that's going to be your quest. So at least sleep, so it has to. And create a new widget blueprint. and base this on our base WBP globe progress bar. I'm going to select that. Really material, right? Anything, because man, really we don't have to change anything. Because its default value is already, so we can do that. Mana glow to the overlay. So we can do that. We can find our drag one in, and I'd like it to be at the same sort of elevation as the health glow anchoring, so it's anchored to the bottom middle. And then I'll select my health globe, which should be anchored to the bottom middle as well, and copy its position Y, and select the blue one, paste for position Y, and now they're at the same elevation. They're not paste for position Y, and now they're at the same elevation. They're not at the Y, which should be anchored to the bottom middle as well, and copy its position Y. And select the blue one, paste for position Y, and now they're at the same elevation. They're not at the exact same distance from the middle, but in both of these anyway in the future. For now, I play, and they are perfect. So we've now seen the power of creating a base widget blueprint with variables that we can inherit in child classes and set them so that we can easily change things without duplicating our work and making multiple widgets that all look similar with just minor changes. This is an easier way to do it. All right, great. So now at this point in time, we're adding the overlay to the screen in our level blueprint, and we know that our widgets have a widget controller variable. That's not even being set. We're never actually creating one of those, but we'd like to drive these health and mana variables from our widget controller, which is going to get the data from the ability system. So we're going to want to create that widget controller somewhere, some way, and in the next video, we're going to decide when and where to do that. So we'll do that next. Great job. I'll see you soon. Just a really quick. Welcome back. Now we have our health and mana globes showing on the screen, but we're adding those from the level blueprint. If we open our level blueprint, we see that we're creating a widget and adding it to the viewport here. That's not what we want to do. That was just for testing purposes. I'm going to go ahead and remove that and close our level blueprint. We don't want that to be something that depends on code in our level blueprint. Instead, I'd like to have a designated place for creating our overlay widget, adding it to the viewport, and later actually assigning its widget controller. Now, our game mode has a number of default classes. If we go to game and BP or a game mode, here are the default classes, and we can set a HUD class. And a HUD class is really good for doing HUD-related things, such as drawing widgets to the screen, and that's where I'd like to add the overlay widget. So I'm going to create a HUD class, and we'll make a Aura HUD C++ class to base our HUD blueprint on. I'll go ahead and close out of all these tabs, and we'll go to C++ classes, Aura public, and this can go into UI, and I'll go ahead and right-click New C++ class, and we'll choose the base class to be HUD. Choosing next. And we'll choose the base class to be HUD, where I can store my Aura HUD class. So I'm going to call this Aura HUD and create class. And I'll go ahead and close the editor, save all, and we should see a HUD folder here in UI. Now, a nice little shortcut in Writer is if you have multiple folders open like this, you can collapse private, you can collapse public, and when you open them again, all those folders are closed, so it looks nice and neat. So in UI, we have HUD. In HUD, we have aurahud.h and aurahud.cpp. Excellent. So what do we want to do in Aura HUD? Well, we want to draw our overlay to the screen, that WBP overlay widget. So I'm going to want to have a variable to store the overlay widget and a variable to store the overlay widget. widget class that I'd like to spawn. So I'm going to go ahead and make a public section and make a variable for the widget itself so we can store it once we've created it. This will be a TObject pointer of type view Aura user widget. Now it's asking if I want to include, I'm just going to add the forward declaration for it. And I'm going to call this overlay widget. This will be the editor, save all, and we should see a HUD folder here in UI. You can collect folders are closed, so it looks nice and neat. So in UI, we have HUD. In HUD, we have aurahud.h and aurahud.cpp. Excellent. So what do we want to do in AuraHUD? Well, we want to draw our overlay to the screen, that WBP overlay widget. So I'm going to want to have a variable to store the overlay widget and a variable to store the overlay widget class that I'd like to spawn. So I'm going to go ahead and make a public section and make a variable for the widget itself so we can store it once we've created it. This will be a TObject pointer of type uAura user widget. Now it's asking if I want to include, I'm just going to add the forward declaration for it. And I'm going to call this overlay widget. This will be the widget. Once we create one, this will get a U property macro. But I also need to know the U class. So to create the widget, I need to know the class of widget to create. So this one, I'll make a private variable. It's going to be a T subclass of. So I'm going to make a T subclass of based on uAura user widget. And I'll call this overlay widget class. And this one gets a U property with edit anywhere. So I can set it from our HUD blueprint. Now we just need a way to add this to the viewport. Now, if we want, we can just add it to the viewport and begin play. For now, just to get things working and see how it works, we can do that. But later, when we're setting our overlay widgets widget controller, timing is going to be important. And we'll cross that bridge when we get there. For now, I just want to see the overlay on the screen drawn by AuraHUD. So I'm going to override begin play. That's a protected function. So we'll make a protected section and we'll say virtual void begin play. That's an override. We're going to go ahead and generate the definition begin play. That's an override. We're going to do the viewport. So first, we need to call create, and now the first input world for that be object pointer. So we're going to create a local one called widget. So we've got our widget, and we can simply add it to the viewport by calling add to viewport. And it looks like writer included something I didn't need there, something you need to print based on that the HUD is going to be your R overlay widget class, and create the Aura HUD blue be your R overlay the widget class, and then playtest. A HUD blueprint, call it B set T. Sign this in the game mode. So go to BP Aura game mode and assign BP Aura HUD for the default HUD class. So pause the video and do this now. Okay, so we can compile and launch. And here in the editor, we can go to Blueprints. And under UI, I'd like a new folder called HUD. And we'll put our HUD in that HUD folder. We'll right-click, make a new Blueprint class, and search for Aura HUD. Choosing that, I'm going to select it and call this BP Aura HUD. Choosing that, I'm going to select Aura HUD. Class in that HUD folder. We'll right-click, make a new Blueprint class, and search for Aura HUD. Choosing that, I'm going to select it and call this BP Aura HUD. And in BP Aura HUD, we can choose our overlay widget class. And here it is under Aura HUD, overlay widget class. We can choose WBP overlay. And compile and save. And then we can go into our game folder. Go to our Aura game mode and change HUD class to BP Aura HUD. Compile and save. And now in begin play, the HUD should construct and add the widget to the viewport. Pressing play, we see that it does, and everything works just fine. So I'm going to save all. This is looking great. We're now ready to start assigning widget controllers to our widgets so that way we can start controlling values in those widgets, such as the percent for our progress bars, or in our case, progress globes. So excellent job. And it looks like Aura has frozen here. It looks like she's played the first idle animation, but it's not looping, is it? Looks like it just stopped. So just a really quick fix. I'm going to go to Blueprints. We'll go to Character, Aura, ABP Aura, and open idle. Select the idle here, and let's check loop animation, compile, and let's make sure that she doesn't just freeze. And let's check loop Blueprints. We'll go to Character, Aura, ABP Aura. First idle animation, but it's not looping, is it? Looks like it just stopped. So just a really quick quick fix. I'm going to go to blueprints. We'll go to character, aura, ABP aura, and open idle. Select the idle here, and let's check loop animation, compile, and let's make sure that she doesn't just freeze after that first idle animation. And now it's looping, and we're looking great. Excellent. All right, I'll see you in the next. Welcome back. Now we're adding our widget to the viewport from the HUD, but we need to give this widget a widget controller. And as we've seen, our widget controller, which we called Aura widget controller, has 4 key variables: player controller, player state, ability system component, and attribute set. Which means if we're going to create a widget controller, we should be setting these variables. So I'd like an easy way to set these 4 key variables. I'd like to create a struct that has these 4 key variables in it, and that will make it easy to initialize any given widget controller. So I'm going to make that struct here in the widget controller class, or a widget controller, right here up at the top, just under our forward declarations. So I'll make a new struct, and I'm going to call this f widget controller params. F widget controller params can be a ustruct, so we'll give it a ustruct macro, and I'm going to make it blueprint type just in case we need to create one of these and use this type in blueprint. And I'll give it a generated body, as ustructs need that, and I'll go ahead and make a default constructor for it, an empty one with an empty body, and I'll make one that can receive the 4 key variables, these 4 here. So I'm going to make another constructor that takes these parameters. So I'm going to make the constructor receive an A player controller pointer. I'm just going to call this PC. I know that's a very non-descriptive name for a parameter, but for these 4 key variables, I'm going to use abbreviations, and whenever I use those abbreviations, you know that I'm talking about these key variables. So after player controller, I'm going to add an A player state input. That's a pointer. We're going to call this PS for player state, and we're also going to have a U ability system component called ASC for ability system component, and a U attribute set. Looks like we need a forward declaration. I'll add that as well here, and this is going to be called AS for attribute set. And I'm going to go ahead and define the constructor right here. So I'm going to use an initializer list that involves a colon, and between the colon and the curly brackets, we initialize the variables right here. Well, this struct doesn't have any, so I'm going to add a few pointers here. I'm going to use TObject pointer, and the first one will be the player controller. That's an A player controller. We'll call it player controller. We'll keep things simple, and this will be initialized to a null pointer. We tend to get compiler warnings when creating structs when their member variables are not initialized, so I'm going to initialize it to null pointer. And this gets a U property. And I'm going to make it edit anywhere and blueprint read write. We'll give full blueprint access all of these variables. So that's going to be the player controller. We're going to need the player state. So we'll make a t-object pointer a player state. This variable will be player state. It'll be initialized to null pointer and gets the same u property access. And next we have ability system component. That'll be a t-object pointer, u ability system component, called ability system component, initialized to null, and given the u property. And finally, our last t-object pointer of type u attribute set, called attribute set, initialized to null with our u property. And now in our constructor, we can initialize these. We can say player controller, and with parentheses, we can initialize it with our PC, input parameter, PC. And these are going to run off the screen. So I'm going to go ahead and, starting at the colon, start these on the next line here. And this will be a comma separated list. This is known as the member initializer list. We're going to initialize player state with PS, ability system component with ASC, and attribute set with AS. And I get red squiggles because it looks like I allowed autocomplete to put aura attribute set here. I actually just want u attribute set. So I don't need to forward declare u aura attribute set either. It's just going to be a u. So I don't need to forward declare u aura attribute set either. It's just going to be a u attribute set here in aura attribute set u attribute set. So I don't need to forward declare u aura attribute set either. It's just going to be a u attribute set here in the aura widget controller class. So now we have a struct that can receive these 4 key variables when we create one. And that's going to make it easy to initialize a widget controller. And in order to do that, I'd like to have a function here in And in order to do that, I'd like to have a function here in Aura Widget Controller that can initialize those values for us. So I'd like a public section and a function for that. Now, I'm just going to call it set widget controller params. And it's going to take a const f widget controller params. We'll pass in a const reference, and I'll call this wc params, or widget controller params. I'll generate the definition, and all widget controller params. Those key variables wc params struct, wc params dot player controller. We also have player state. So now we can simple controller params. And the widget controller will set its member variables. And I'll go ahead and make this a U function with blueprint callable so we can set it if we need to from blueprint. And now we have a way to set those variables. Okay, so now our widget controller has a way to set those variables. We're going to want to actually create an object of this widget controller, but I'd like to use Aura widget controller as a sort of base class. So all of our widget controllers will inherit these properties. And for our overlay, I'd like to create a specific overlay widget controller. So I'm going to make a child class based on Aura widget controller. So I'm going to go ahead and compile and launch the editor so I can make that child class. So opening all the assets that I had open, looks like I still have AVP Aura. I can close that. I can close Aura Game Mode and Aura HUD, and I'm going to make the new C++ class that I want. So C++ classes, Aura, public, and here in UI, we have the widget controller. I'm going to make a widget controller based on Aura widget controller. So I'm going to right-click, create a C++ class, and I can let this live in the widget controller. Right-click, create a C++ class, and I can let this live in the widget controller folder, and this is going to be called overlay widget controller. So we'll go ahead and create this class and close the editor. And now that I have an overlay widget controller, this is the one I want to create. So here in the UI folder, we have widget controller, there's Aura widget controller, that'll be our sort of base class, and we have overlay widget controller. And that's the one I want to construct. Now, I'm going to construct this in the HUD class. I think the HUD is a good class to create both the overlay widget and the widget controller itself. So I'm going to make a function to create the widget controller. Now, I'd like this function to create the widget controller if it hasn't been created yet. And if it has, just return that widget controller. In other words, we'll only ever have one overlay widget controller. It's kind of treated like a singleton in a sense that we'll only be able to get it through a getter that will create it if it doesn't exist yet. So I'm going to make that getter. It's going to be public, and it's going to return a U overlay widget controller. That's the class we just created. And we're going to add a forward declaration for that. And this function will be called get overlay widget controller, and it can take a const reference to some f widget controller. We're going to call it widget controller params. So up here with our forward declarations, I'm going to say struct fWidgetController params. And let's generate this getter. And the getter is going to check to see if one of these has already been created. So if one has been created, we should store it in a pointer. So AuraHUD is also going to get a pointer to store that overlay widget controller. So here in the private section, we're going to have a U overlay widget controller. That's a pointer. We'll make it a T object pointer. And we'll call this overlay widget controller. And for now, we'll give it a U property with no specifiers. And here in AuraHUD, we're going to check to see if it's a null pointer or not. So we'll say if overlay widget controller is a null pointer. If it is a null pointer, we'll create one. And if it's not a null pointer, well, then we'll just return the non-null widget controller. So we'll return right here, overlay widget controller. But if it's null, we need to create one first. So we'll create one. We'll say overlay widget controller equals, and we'll use new object. So new object is how we can create a U object. We're going to create a U overlay widget controller. Notice that writer just included that header for us. And for new object, we need to pass in the outer, which is going to be the HUD itself. And we also need the U class. So AuraHUD needs to have a U class. In other words, we should make a T subclass of for the overlay widget controller class itself. So just like we have the overlay widget class, we need an overlay widget controller class. That'll be a T subclass of U overlay widget controller, and this will be overlay widget controller class. And this gets a U property, but we also have to be able to set this from the blueprint, so we'll make it edit anywhere. And backend have to be able to set this from the blueprint, so we'll make it edit anywhere. And back in the CPP file, we'll pass that class into new object, so overlay widget controller class. So here we're setting our member variable overlay widget controller. We've just created a new one. And we should set its widget controller params. So this getter takes WC params. So we can take our overlay widget controller and call that public function that we created called set widget controller params and pass in WC params. And that way those key variables will be set. And once we've created one of these, we can return overlay widget controller. So now we have this getter that will construct it for the first time if it hasn't been constructed yet, but if it already has, it won't be null, and we'll just return it without constructing anything. So in order to get it, we have to pass in those WC params for it to have its key variable set. So now that we have that getter, we now need to construct our widget controller, but we see that in order to construct it, we need widget controller params, and to initialize widget controller params, we need those 4 key variables, which we don't really have access to in begin play here. So essentially, we need to do this somewhere where we have access to those 4 key variables. So what I'd like is for the HUD to have a function we can call and pass in those 4 key variables. That way we can create that widget controller and assign it to our widget. So rather than doing all this in begin play, I'd rather do it in a function that can take those key variables. So we're going to make a function here in Aura HUD. It's going to be a void function. We'll call it init overlay. And it's going to take the 4 key variables: an A player controller, we'll call it PC, an A player state, we'll call it PS, these are pointers, a U ability system component, I'll add the forward declaration and call this ASC, and a U attribute set will add a forward declaration and an overlay and AS. And we'll make the definition for init overlay and an AS. And we'll make the definition for an init overlay, and init overlay is going to construct the widget controller, construct the widget, set the widget's widget controller, and add it to the viewport. We'll take all those things and tie them all together here. So we're not going to do it in begin play anymore. I'm going to go ahead and just remove begin play. But these 2 lines, we can go ahead and cut and paste them into init overlay first. And then we're done with begin play. I'm going to delete begin play. I'm going to delete it from aurahud.h as well. And here in init overlay is where we're going to actually do everything. Now, first of all, init overlay needs to create 2 things now. We need to create a widget and a widget controller. So what I'd like to do is perform a check, but if that check fails and we crash the engine, I'd like to provide a more descriptive crash message. So for that, I'm going to use check F. Check F will check a condition and then print a formatted string to the crash log if the check fails. So I'm going to check, first of all, overlay widget class. We need that to be set. And if we fail, then we'll use the following message. We'll say overlay widget class uninitialized, please fill out BP Aura HUD. And we'll do the same thing for the widget controller as well. So we'll say check F, overlay widget controller class, and we'll say for the text, overlay widget controller class uninitialized, please fill out BP Aura HUD. So that way we definitely won't forget. So first we need to create a widget. We'll call it widget, and we're going to want to create the widget controller controller as well. So I'm going to wait to add this widget to the viewport till the very end, and I'm going to cast widget to Aura user widget. That way we can set its widget controller. So that way I can set my overlay widget. Remember, we have this overlay cast widget to the viewport till the very end, and I'm going to cast widget to Aura user widget. That way we can set its widget controller. So that way I can set my overlay widget. Remember, we have this overlay widget, which is an Aura user widget. So I'm going to say overlay widget equals, we're going to cast to Aura user widget, and we're casting widget. Now we have access to overlay widgets Aura user widget stuff, like set widget controller and so on. But we have to create that widget controller first. So next, we create the widget controller, and I'm going to make a f widget controller params struct. I'm going to call it widget controller params. And remember, this has a constructor that takes the 4 key variables. We'll just briefly go back to Aura widget controller to remind ourselves. We'll scroll up and see that constructor. It takes player controller, player state, ASC, and AS. Let's initialize the widget controller params because init overlay takes those key variables. We can initialize it with PC, PS, ASC, and AS. And now this struct contains those. And really, we could make this a const struct. There's no need to make it mutable. And now that we have those params, we can now construct the widget controller because Aura HUD has get overlay widget controller. It requires the params. It's going to be null the first time, our overlay widget controller. So it's going to construct the widget controller, set its widget controller params, and return one. So what we'll do here is we'll call that function and store its result in a overlay widget controller. So we'll make that pointer. We'll call it overlay widget controller, and we'll initialize it with get overlay widget controller. And as we can see, it requires the f widget controller params. We have one here called widget controller params. We'll pass that in. Params we have controller, and we'll initialize it with get overlay widget controller. And as we can see, it requires the f widget controller params. We have one here called widget controller params. We'll pass that in just like that. And now we have the overlay widget widget controller. So now that we've constructed the overlay widget, we've constructed the overlay widget controller, we need to tie the two together by taking overlay widget and calling set widget controller, passing in overlay widget controller. And after that, we can add it to the viewport. And in Aura HUD line 30, looks like I'm hiding a class member, overlay widget controller here. Looks like we made this a member variable. So I'm going to actually call this simply widget controller and pass that into set widget controller. That way, I'm not actually hiding a member variable. So now we have this function in the HUD called init overlay. And as long as we can pass in the player controller, the player state, the ability system component, and the attribute set, then init overlay can construct both the overlay and its widget controller and set the overlay widget's widget controller before adding it to the viewport. So this init overlay sort of does everything for us. We just need to be able to pass in all that information. So the question is, when and where do we call init overlay? When do we have access to all of these? When do we know that they're all initialized with valid data already? And that's going to be your quest. Now, this quest requires you to do a little bit of thinking. Your objective here is to call init overlay, but decide where to call it. Where should we call it? When and where are we going to know all the key variables are initialized? This is going to make us think back to where we had to make sure our player controller was already set for the character and our player state was already set back when we had to init ability actor info. So there's a hint for you. So decide where you need to call this. Make sure you take care of both cases, the server and the client. And once you're calling that function, you can playtest and make sure you get that widget added to the viewport. So pause the video and try this quest now. Okay, so we now have this nice function that ties everything together in the HUD. And here is where we create the widget controller, set that widget controller on the widget, and add it to the viewport. But this function requires the player controller, the player state, the ability system component, and the attribute set. So where do we know that those are initialized already? Well, you might have thought that we could go into Aura character, into init ability actor info. This is a pretty good spot, right? It's called in possessed by and on rep player state, taken care of for the server and the client. And here is where we already know the controller is set, and we also know that we have a player state, right? We're checking the Aura player state here. So there's two of our key variables. And also, we have the ability system component and the attribute set. We have all four of the key variables here. This is a great place to do it. Now, we need to access the HUD. And the HUD is always accessible through the player controller. So what we can do is we can get our player controller. The character class has get controller. And of course, this returns a controller. So we have to cast it to a player controller. In fact, we can cast it directly to our player controller class. What is that? That's, of course, Aura player controller. That's a Aura player controller. We can cast right away. And we can store this in an Aura player controller pointer called Aura player controller. Now the question arises, do we check this pointer, make sure it's not null? Or are we sure that it'll never be null? Or should we place a check here? Should it never be null? Is there a problem if it's null? This is a pretty common question, and a lot of newer developers sort of struggle to understand when to null check and when to perform an assert, like check, and it helps to understand the player controller and whether or not it exists on all machines for all players. And we can recall back in our multiplayer discussion that only on the server are all player controllers valid. The server has all the players' player controllers, but each player has only its own player controller. So on a client's machine who is controlling that specific character, that player controller is valid, but the other characters on that client's machine who are not locally controlled, those do not have valid player controllers. So say in a 3-player game, for example, if you're a client, your player controller is valid, but on your machine, the other 2 characters, those 2 copies, do not have valid player controllers. And init ability actor info, this function, will be called, and Aura player controller will be a null pointer in that case. So in this scenario, for this function, Aura player controller can and will be null in multiplayer, and that's okay. We only want to continue if it's not null. So we'll place an if check and wrap this in an if check, and that way, only if Aura player controller is not a null pointer do we continue. So this is the case where we check the null pointer and don't place an assert because we don't want to crash in this case. Now, this brings up an interesting point. Is there anywhere else in our code that's like that? Well, there is one, and just as a bit of a tangent, I'm going to show you that. If we go to auraplayercontroller.cpp, right here in Begin Play, we're checking the subsystem, and we're calling add mapping context here, but really in Begin Play for Aura Player Controller, we're not going to get a valid subsystem unless we're on the locally controlled machine who has a valid local player here. So this is one of those cases where we should check the subsystem instead of using an assert that says check. So really quick, we can just say if subsystem here, and place that subsystem call right there, and now this will work in multiplayer. So that's kind of an important detail now that we're thinking about multiplayer. So we'll make that change and close Aura Player Controller and come back to Aura Character in Init Ability Actor Info, where we're getting Aura. Come back to Aura Character in Init Ability Actor Info, where we're getting Aura Player Controller. Now from Aura Player Controller, we can get the HUD. So we can take Aura Player Controller, we can call get HUD, and this returns a HUD, right? But we want an Aura HUD. So we're going to cast this to a Aura HUD. And we have a valid player controller. We want a valid HUD as well. So we'll make a local Aura HUD called Aura HUD, and we'll place that in an if check to make sure that it's valid. Because remember, the HUD is only valid for the locally controlled player. So if Aura HUD is valid, now we have access to Aura HUD, and we can finally call that function on Aura HUD, which we called init overlay, which takes the 4 key variables. We need the player controller. We can pass in Aura player controller. We need the player state. We can pass in Aura player state. We need ability system component. That's going to be ability system component. And finally, an attribute set. That's going to be attribute set. And now init ability actor info is complete. And we can go ahead and test this out. Now I'm going to run in debug mode. All right, so we've opened the editor. We're running in debug mode. I'm going to go to Blueprints, UI HUD, open BP Aura HUD, and we have overlay widget class and overlay widget controller class. Now, we don't have a blueprint for overlay widget controller. That's okay, we can set it to the C++ class for now, but eventually our overlay widget controller may wish to have some data on it that we can set from Blueprint. So we'll keep that in mind. But let's go ahead and hit play, and there we have it. Our health and mana globes are being displayed on the screen, and that's all being drawn from the Aura HUD, thanks to our nice function init overlay, and we know that our widget controller is being created, and it's being set on our overlay widget. And just before we wrap up, we can prove to ourselves that that widget controller is being set. How can we do that? Well, we can go into the WBP overlay widget, go into its graph, and right click, and we have a widget controller set event. Remember, we added this to Aura user widget. And if event widget controller set is fired off, that means we've set the widget controller. And in fact, we can search for widget controller, and here's the get widget controller. That's the get for that variable that is our widget controller. Here in Blueprints, we can use get object name to get a string with that object name, and we can use print string to print it to the screen. And now if we go ahead and hit play, we see overlay widget controller underscore 0. That's the name of the widget controller. So we know that the widget controller is set as well. And we're overlay widget controller, and now if we go ahead and hit play, we see overlay widget controller underscore 0. That's the name of the widget controller. So we know that the widget controller is set as well. And we're running this in debug mode, which means if we want, we can place a breakpoint anywhere, such as in init overlay. If I place a breakpoint at the very last line, where we're calling add to viewport, well, now if we press play, we'll hit that breakpoint. And here's where we're starting to see the benefit of having symbols, because now check this out. Down here, we have a lot of things popping up and showing us values. So when this function init overlay gets called, we see that this is BP Aura HUD underscore C. So we know inside this function, this holds a blueprint, the Aura HUD blueprint. That's pretty cool. And we know that PC, this local input parameter, local to init overlay, has a valid value. Look, it's set to BP Aura player controller. How about that? And we can hover over it and see that. In fact, hovering over it, we see its memory address, we see its name, and if we click plus, we get a drop down. This is all writer specific, but Visual Studio also has debug capabilities. We see that the player controller has last actor and this actor set to null. Those are those enemy interface pointers. And so we have the ability to see all kinds of information. So that's really, really cool. And by the way, I'm just now remembering last actor and this actor were raw pointers, right? We didn't use t-object pointer, and we can see that here. And if we want that to be a t-object pointer, we really could change it to t-object pointer and keep up with that standard. So hey there, Stephen from the future here, coming back to let you know that what I said in this video is incorrect. We cannot use a t-object pointer for an interface such as our enemy interface. That is not correct. What we need to use instead is a t-script interface. Please refer back to section 2 in the Highlight Enemies lecture, where we use the t-script interface instead of enemy interface. That was an addition to the course. So please make sure that you're using a t-script interface and not a raw pointer or a t-object pointer for your last actor and this actor. Very important, use t-script interface. Now that widget controller can start really controlling the widgets that have their widget controller set to it, and we're going to see that power in the videos to come. So excellent job, and I'll see you in the next video. Broadcasting from our